Good morning, everybody. So today is Alan Turing's 100th birthday, or what would have been his 100th birthday had he lived long enough. For those of you who do not know who Alan Turing was, he's basically responsible for everything we know about computers today. He was born back in 1912, obviously, June 23rd. This would have been his 100th birthday. And he was a British mathematician and cryptanalyst and computer scientist. This guy was just a genius all around. He did a lot of work in World War II with breaking a lot of the German codes and all things that they used to encrypt their information. Problem was, in the 50s, 52, 54, somewhere around there, he was found out to be gay. And at that time frame, it was illegal to be gay in England. And they gave him two choices: imprisonment or chemical castration, hormonal changes to try to overcome his quote-unquote gayness. He chose that, the second option, until he eventually killed himself. There is some theory about whether or not he killed himself, or he was killed, or it was an accident, but he ate a cyanide-laced apple. I'm not really sure how you can accidentally do that. I don't know how many apples are out there with cyanide where you could just pick one up by mistake. Don't know. In any event, in honor of his 100th birthday, Google has released a new Google Doodle. And as you see here at the top of the Google page, like always, they've got something changed. Now what we have here is a Turing machine. And you can click start and Google will all go gray. And then we can use the logic of the Turing machine to light Google back up, basically. So let's take a look. Here's how it goes. Click start. Google goes dead. I have 00010. I mean, it is 01011. That is the binary code. Here on the right will be a little check indicator. Now, I've already worked through the logic on this, and you'll see it'll verify it. Now, the first one's not that difficult, but they get progressively harder. And there you go. We've got our G. Now we need 3 zeros and a 1. This is the equivalent of a binary 3. This button gives us 3 choices: 0, 1, or a blank. Now we got a 0 in there. And you need to know all about binary math for starters. A 0 and a 1 make a 1. A 0 and a 0 make a 0. A 1 and a 1 make a 0. It's a little bit confusing, but if you know binary math, this is not too tough. Okay, this one, every time I click this, you'll see this bar stretches out. I'm going to want to go all the way to the furthest point here and click start. And you see these light up as it follows its train of thought. There we go. Okay. There's our second O. And next one. Nope. That should do the trick. Okay, let's get the L going. Another blank on this one. Looks like it would be correct. Up, around, down. There we go. So the way computers process 0 and 1s is really something that Alan Turing came up with, and that's why he's responsible for what we know about computers today. He really is the father of these kinds of computations. As we know, computers think. We got a 1 here and a 1 in the box. Leave these as zeros. Okay. As we know, computers think in 1s and 0s. Everything we do gets changed to a 1 and a 0. You know, A is represented as 1010 in computer machine language. And the way he allowed the logic to flow and figured it out created the situation we have today. So he started this whole thing off in the early 40s. So you saw here, Google got colored in, went blank. It's going to repeat it all at once now for us, following that path of what I put in. And we're going to light up the whole word Google. Here's the exciting thing about it. When you go back a second time, it starts you all over again, but not with the same ones. So now you need the same pattern of ones, like we wanted the last time, but a whole different logic pattern. So you can do this over and over again and get progressively harder as you go through it. So there you go. Have some fun. Try it out. Let me know what you think.